Right, good morning, my fellow South Africans. Today we're looking at trigonometry. The focus of today's lesson will be special angles, and this is right up until from grade 10 up until grade 12. Now, if you talk about special angles, we have our special angles comes from our triangles, and the first one is the one that looks like this, where we say, but this is called a what type of triangle again?
Right angle triangle.
Alright, so trigonometry, we established yesterday that trigonometry is, what is trigonometry? It is the study of angles and sides and the measurement of those in right angle triangles. That is basically what trigonometry is. And if we have the basic of trigonometry, namely sine, cos, and tan. Basic trigonometry functions, and then we also say today's topic is going to be the special angles. Now the special angles comes from this is a specific type of triangle, namely an isosceles triangle, meaning the legs are the same. So if we say that these are the same, that means that is going to be 45 and that is also going to be 45. Alright? Then we can say, okay, but let's give that a length 1, and that is going to be a length 1. Alright? So because both of the lengths is 1, so I don't currently know what is the hypotenuse here, but I can work out the hypotenuse, and I can say the hypotenuse, if this is now y and this is x, I can say the hypotenuse is normally determined by the
Radial.
theorem of Pythagoras. So we can say r squared is equals to x squared plus y squared, and then I just do simple substitution, and 1 squared plus 1 squared is 1, and that's going to be square root of 2. Okay, so the answer there is square root of 2. Alright? And that gives me a 45 and a 45 there. Now if I ask you, for example, the sine of 45 degrees, it's going to be, I'm standing from this perspective, or I can stand in that perspective, and I'm going to say the sine is 1 over square root 2. So your answer is 1 over square root 2. Now then, we normally ask you to do this without the calculator, then you would have to have a sketch or something like that. I can also ask you cos of 45, and then that will also be 1 over square root 2. Okay? Then, and tan of 45? 1 over 1, which equals to 1. Then if we go, there's another triangle which looks a little bit something, I can't recall correctly. I think this is probably 60. That is 30, and I hope this is 1, and that means this is 2. What will be the square root 3? You can work that out by Pythagoras, alright? And there's my 90 degrees. So what we have here is we can also establish the sine of 30 is going to be
Opposite of 2 over square root of 3.
I'm looking from that perspective. So what is sine? It's opposite. Sine, remember, is opposite of hypotenuse. So what is the opposite? Sorry. Yeah. That's 2. That's square root 3. Thank you. So what is it going to be? It's 1 over 2. No? This cos of 30 is going to be, what is cos again?
Adjacent over
Adjacent over
hypotenuse.
hypotenuse. And that's going to be equals to? Square root 3 over 2. What else there? Tan of 30 is going to be equals to?
Opposite over opposite
1 over square root 3. Oh yeah, that is what I actually wanted to come back to. Now, you will see when you type these answers into your calculator, especially when there is a third in the denominator, we call, you will not get this answer, you will rather get on your calculator square root 2 over 2. And here you will also get square root 2 over 2. Now what happens there is your calculator does something which we were taught in the first term, which we call as rationalize the denominator. That means we don't not want a certain number in the denominator. So all that we do is we multiply by square root 2, and that becomes 2. But what we need to do in the bottom, we need to repeat on top. And the same goes here. If you type this into your calculator, tan of 30, your calculator automatically is going to, what do we call that process? Rationalize the denominator. So if they can ask you, for example, when you are writing paper 1 at the end of the year, they will can give you something like this, and they can ask you rationalize the denominator. Then you just need to get rid of the third in the denominator, and all you have to do in this case is we are multiplying by square root 3 over square root 3. So that now becomes equals to 3 square root 3 over 3, and that's your answers as you get it from your calculator. Okay? Just recapping on some basic algebra. And from this two triangles, we can also get, what is the other one? Sine of 60, which is going to be square root 3 over 2, cos of 60, which equals to 1 over 2, and tan of 60, which equals to square root 3 over 1, which just equals to square root 3. Everyone good with that? Alright, now sometimes we refer to these two, the next two, as the impossible. It's actually one triangle, but I'm going to draw it in two ways. It is what I sometimes recall that the impossible triangle. Alright, so we have here also an isosceles triangle, but this, I'm just drawing it like this, but it's basically which we have. What do we need for a triangle? We need 3 sides and 3 angles. Alright, so we need here to create a triangle, another side. But what if that third side, say the angle now, this, I'm looking from this angle here, and this angle becomes closer and closer, and the angle is actually 0. How long is this side going to be? The length is going to be 0. So if we look at there as a 0 degree angle, that means the length right here will also be 0. But let's say that length and that length is the length of the Skokie, so we say it's 1. No? So we have what we call the impossible triangle, and then we have here 90 to 90 degrees. Now we can use this and manipulate it, and we can also say the sine of, say for example, the sine of 0. So I'm going to stand in that perspective, and I'm looking down. What is the sine of 0? It's going to be, what is the sign again? Opposite over hypotenuse. So what is the sign going to be? 0
over 1.
Over 1, which equals to
0.
If I do cos of 0, what is it going to be?
Adjacent over.
Adjacent. So what is my adjacent side?
Still 1.
1? No? Over 1.
Which is 1.
Which equals to 1. And if I do tan of 0, what do I get? 0 over, no, just 0. No? So, but we can also change our perspective from where we are standing here, and we can say, okay, but I'm going to stand here. So I'm changing this perspective. I'm not going to put Luke here today. I'm not going to have Lisa Kanya because it was a little too big for the board yesterday. No, almost fell off. It was had too big muscles. So today we're putting Luke on the board. Luke is going to look from this perspective, and we're going to ask Luke, what is the sine of 90? So I'm standing from this perspective. What is sine again? The question. Sine's ratio is opposite
over hypotenuse.
Now what is the opposite here? If I'm standing in this corner, 1 over 1. So that's 1 over 1, which equals to 1. I want you to remember these questions you are supposed to be able to do without the calculator, and that's why I ask you in the morning when you come into class, I'm going to ask you what is the sine of 90 and stuff. Because if you can recall this, and I'll show you a quick cheat how to remember this quickly now. Just check, just confirm with me if you type in all of these answers, if it is so on the calculator. Alright? And then we can get cos of 90. Luke is standing here. Luke is looking from that perspective. What is the cos of 90 going to be?
0.
So going to be. So what is cos again? Cos is?
Adjacent over
So
hypotenuse.
it's actually 0 over 1, which equals to 0. And then the tan of 90.
Opposite over adjacent.
What is, so he's standing here. What is tan again?
Opposite over
Opposite.
adjacent.
1. 1 over 0. And 1 divided by 0 is undefined, because we know that division through 0 is undefined or is not allowable. Okay? So that's what we have here. Let me just, because before we started with trigonometry in grade 11, I gave you a brief glance at trigonometric graphs. So another way how you can look at this is that if you know your graphs, I'm going to do the sine graph, which looks like that. So this is y is equals to sine of x, where this is 0, this is 180, this is 360, so the half of that will be 270, and that will be 90. You're supposed to know that it is the sine graph like that. And then if I put in my y values, and let's say that is the y value there is 1, and that makes this negative 1. So that will be 270 will be negative 1, that will be 0, and that will be 90 and 1. If I substitute, 90 into there, what do I get?
1.
You see? Yeah. And along this curve, if you substitute it, go there and you get the 60 angle, you'll get a half. If you go by the sine graph, and you will get, sine 30 is going to be a half, and 60 is going to be the square root of 3 over 2, you'll get that answer. So it's also, you can actually read it off from those values. The same we can do for the cos graph. The cos looks something like that. So where this is 0, that is 1, this is 0 and negative 1, this value there is going to be 90, this is 180, this is 270, and this is 360 is right there, and that is 360, and y value is 1, this is 180 and negative 1. And so we can determine those values from that as well. How does my tan graph look? My tan graph looks something like this. Now you see why 90 was undefined, because why was 90 undefined? It is an asymptote, and so as well as x is equals to negative 90. So we know our tan graph has a basic shape that goes something like that. With tan of 45, and Mr. Davids answered that question. I don't know if it was a lucky guess or something, but I asked him tan of 45, and he said that tan of 45 is equals to 1, which means that where x is equals to 45, there my y is equals to 1, and there we cross at 0. That's your basic stuff for all of these angles. Let me show you a cheat, because I was very lazy and I didn't have a good memory on school. What I did, I taught myself a trick. So what you do is, when they ask you and all that you need to remember, there's a lot of information, and the more and more you practice, the more you can remember this. But let me show you a quick trick. Is you go draw a table, because if you sit around the table, you have a lot of engaging conversation. So I think it is T, what is T in English? O and H. Yes. Alright, so that will be the 30, 60 and 45. Now you need to pay careful attention to what I'm going to do next. Right here, we have all of the twos. No? Did you see? All of the twos, and right there in the diagonal, we have all of the square roots. So in the diagonal, we have the square roots. In the H column, we have all of the twos. And then, if you can remember that, you don't even have to think. Then it's almost like playing Sudoku or Omo, whatever game you like to play. No? So now they can ask me the sine of 30. What is the sine of 30? What is, I go to 30, no, I don't really remember any of these triangles, I go 30 is sine opposite over hypotenuse. If they ask me the cos of 30, I go by 30. What is cos again? Adjacent over hypotenuse, square root 3 over 2. If they ask me tan of 45, what is tan again? It is adjacent. Sorry, opposite over adjacent, so it's 1 over 1. If they ask me the cos of 45, what am I going to say? Cos is adjacent over hypotenuse, so there's my adjacent is 1 over square root 2. So there is some knowledge, and today's lesson was only about special angles and how they are useful today. Alright, I'm going to allow you now to continue with the notes, and you can also make a brief summary of this for yourself, of everything, and I thank you guys.
Thank you.
Don't forget to subscribe, like, comment. If you are here in 2030 coming back to visit this video, maybe you're doing trigonometry there when you're building a bridge. If you're alive, because you're building bridges, you don't down bridges. Send a shout out to me if I'm still alive. Yeah? Thank you guys. Thank you, Lisa Kanya.